Esta sesión va a ser prácticamente en español, pero sí que hay una sesión única en inglés que está a cargo de Boris Behncke. Él nació, bueno, lo voy a decir en inglés, pues he born in Germany. Boris Behncke is a volcanologist working with the Italian National Institute of Geophysics and Volcanology in Catania near the Mount Etna. After frequently visiting the Italian volcanoes since the late of 18th, he moved to Sicily in early 97, and he did his PhD in the University of Catania. His studies are focused on the eruptive dynamic and deposition processes, foremost at the Sicilian volcanoes such as Etna, Stromboli, and related hazards that concern the local community, their infrastructure, and economies. In recent years, much of his time and effort is dedicated to the communicating and public outreach, and he's part of the INGV, Volcano Department Communication Group, that disseminate information about the volcanoes in Italy and beyond to the general public using social media and dedicated blog like ngvvolcani.com. So thank you so much. Boris, can you hear us? Yes? So you've got 20 minutes, so the stage is yours. Thank you so much.
Okay, buenas tardes, and I'm very, very glad to do this little presentation. I would have rather liked to be there with you physically, but I hope that there will be another occasion maybe next year. Anyhow, I'll now go into the presentation mode, and let me see where it is. Where is my presentation? Because I have my presentation open. Okay, let me see if it works. Do you see the presentation?
Yes, we see it. Thank you.
Yes, wonderful. So the idea is to talk about aspects, marine hazard aspects at our two active volcanoes here in Sicily, which is one is Etna, which is just over there, although it is currently in the clouds. And the other one is about 100 kilometers to the north here in the Aeolian Islands, and it is called Stromboli. Both volcanoes are often told to be also present hazards which would have marine impact. So let us see what exactly they are. At Etna, it is known that there is a vast zone of instability of different sectors of the flank of the volcano, mostly the eastern side that you can see here at right, which is moving toward the sea. And then there are other sectors which are moving less rapidly. And there's quite a bit of debate about the cause of this flank instability and this flank mobility. Some scientists say that it is due to gravitational pull. But others say that it is rather something that has to do with the internal dynamics of the volcano. And indeed, 7 years ago, there was a publication which caused a lot of uproar, also here in the public and the population, where it was said that the eastern flank of Etna was collapsing due to gravitational forces. And the thing is that the author said that it cannot be excluded that flank movement will evolve into catastrophic collapse, which is something that we know from many other volcanoes, including the Canary Islands and Hawaii, where there have been gigantic volcanic landslides in the past. And so Etna has also been described as a candidate. The heart of this unstable area is the so-called Valle del Bove, the Valley of the Oxen, which is a huge depression formed by probably a sequence of landslides, major sector collapse events, which occurred between 8,000 and 9,000 years ago, and which is in the middle of that sector of the volcano, which is unstable, which is mobile, which is moving, and it is moving actually continuously at an average speed of 2 centimeters per year, but this can accelerate in certain periods, like in 1984, 2002, and in 2018, when there were also movements by several meters. And the thing is that almost 20 years ago, a publication in the Journal of Geophysical Research proposed that the Valle del Bove collapse some 9,000 years ago triggered a giant tsunami, a mega tsunami, which went all through the west-eastern Mediterranean and caused devastation along the coasts. And this was due to a single gigantic collapse of, it was estimated something like 14 cubic kilometers of rock from the eastern flank of Etna. Today, there is basically consensus that there was not one single collapse, but there were several smaller events, each of which might have caused more local tsunamis, smaller tsunamis, but that there was also certainly quite a lot of erosion that contributed to the formation of this huge depression of the Valle del Bove in the eastern side of Etna. And the question whether this flank movement is induced by gravitational slip, gravitational pull, or by internal dynamics of the volcano was in part answered at Christmas of 2018, when there was a very forceful intrusion of magma into the southeastern flank of the volcano, which also triggered an eruption. And this led to a slip that amounted to approximately 1 meter in certain areas. And this large movement of the eastern sector of the volcano was clearly triggered by the intrusion of magma, and not vice versa, because the slip occurred after the beginning of the intrusion. And we had a similar event also in 2002 on the northeastern side of Etna. And presumably there have been also earlier episodes, one in 1984 and others in the 1950s, the 1910s, and so on. And so it is presumed that Etna is capable of accommodating the instability of the flank in these relatively small, though dramatic events for the population, and very intriguing for the scientists, obviously. But that this is what possibly precludes a catastrophic single collapse, but rather this movement of the flank of the volcano occurs in many small events. Now we come to the other volcano, which shows instabilities, and this is Stromboli, an active island volcano, the northernmost of the Aeolian Islands to the north of Sicily. This is a rather large volcano, of which only the upper third rises above the sea level to about 925 meters, whereas an additional 2,000 meters of this volcano lie below the sea level. It is a very typical calc-alkaline stratovolcano with steep flanks, and typical for such steep island volcanoes, there is a lot of instability there, which periodically leads to collapse of the unstable flanks of the volcano, especially one, which is the northwestern side, which is called the Sierra del Fuoco, and where we now know from geological data that there have been repeated sector collapse events over the past few thousand years, a rather big one about 5,000 years ago. Here we can see a digital model of the Sierra del Fuoco. It's this horseshoe-shaped collapse scar, within which the volcano is actually reconstructing its edifice, and therefore this is growing more and more unstable. And so it's estimated, the Sierra del Fuoco was mainly formed about 5,000 years ago, possibly due to excessive weight of the materials that are accumulating due to the persistent, continuous activity of this volcano, but possibly also destabilized by magmatic intrusions. And what we have already seen here before is that this scar continues down below the sea level, almost to the base of the volcano, so even beyond 700 meters depth. And since the persistent activity of the volcano constantly adds material to this scree of the Sierra del Fuoco, it is considered that it is always prone to some collapse. And such a collapse occurred, for instance, on the 30th of December of 2002, when a part of the slope collapsed both above and below the sea level. Probably it started below the sea level, and it removed about 40 million cubic meters, which slid into the sea and caused a tsunami that caused a lot of destruction on the near shore areas of the island. And then relatively recent evidence shows that there was probably a much bigger collapse in the Middle Ages, about 1343, which is said to have caused a tsunami, and the tsunami practically sank all ships that were in the harbor of Napoli, which is some 150 to 200 kilometers to the north of Stromboli. And here we see a few scenes of this collapse in December of 2002. It happened during an eruption that produced a lava flow. We can see a little bit of glowing lava here on the right. And there was a lot of sliding of material. There were also pyroclastic flows, as we see in these images. And this whole sector where the lava came down eventually detached and rushed down into the sea. And there was interaction of hot rock interacting with the seawater, and this generated a huge plume of steam and ash. And tsunami was generated that ran up to 10 meters above the sea level. And we see here a few people running from the tsunami, which invaded low-lying areas, devastated a lot of buildings along the coast. Luckily, it was the 30th of December, and so there was nobody on the beach, and only a few people were mostly lightly injured. But often we have wondered, what if this happens in the summer? And we've had, since then, eruptive episodes in the summer, like in July and August of 2019, and also again in July of last year, when there were small collapses and there were pyroclastic flows that ran into the sea and caused very small tsunamis. And so since 2002, a system has been installed to warn of tsunamis directly. There are two buoys placed before the Sierra del Fuoco. These are run by the University of Florence, which is collaborating with our institute, the INGV, in the monitoring of Stromboli and obviously also the tsunami risk. And so these buoys measure, obviously, variations in the sea level. And when there's a certain spike noted in the sea level, then a warning goes out to civil defense, which is then also published, because a tsunami from Stromboli might affect vast areas of the coast of northern Sicily, Calabria, and the region of Campania up to Naples. And I think this is the final image, so this is a very brief presentation, actually. After the tsunami in 2004, triggered by the huge earthquake in Sumatra and Andaman Islands, which caused a devastating, deadly tsunami in the Indian Ocean in December of 2004, there has been also heightened attention in Italy and in the Mediterranean area toward the tsunami risk in the Mediterranean. And so the Mediterranean Tsunami Warning Center has been created, which is run by our institute in the main seat in Rome. It's called the Tsunami Alert Center, or Centro Allerta Tsunami. We also have the website here where you can actually look up information about the work of the center, and obviously information which is given when there is a warning of tsunami. And so with this, I'm practically at the end, almost at the end. So what we have seen from the little bit that I have told you is that there is a lot of flank dynamics at Etna, but it is currently considered that there is a very, very low risk of tsunami caused by the dynamics of Etna. Whereas Stromboli is considered a site where the risk of tsunami is rather high. And each time when this volcano enters into a phase of heightened activity, obviously there's also very much heightened attention to the probability of flank movement. The whole scree of the Shadow del Fuoco is actually under surveillance of instruments, even like INSAR and other strain meters, in order to discover displacement of the flank of the Shadow del Fuoco in real time, hopefully, before there's a massive failure that might trigger a tsunami. And with this, I've come to this place here, and I tell you muchas gracias from Mount Etna, and hopefully I'll be soon